Hey, how's it going on, guys? So in this video, we'll discuss about this problem, random pick with weight. Given an array W of positive integers, where Wi describes the weight of index I, write a function pickIndex which randomly picks an index in proportion to its weight. Note, W.length lies between 1 to 10 to the power 4, Wi lies between 1 to 10 to the power 5, and pickIndex will be called at most 10,000 times. So let us see how we can solve this problem. So in order to solve this problem, first try to understand what this problem is. So let us consider this array given to us, that is 2, 5 and 3. Now from this array, we have to pick either index 0 or 1 or 2. And the basis will be based upon the weights of these index. So for 0, the weight is 2. For 1, the weight is 5. And for 2, the weight is 3. So what is the probability that we will pick the index 0? This will be equal to the weight of 0, which is 2, divided by the total weight, that is 2 plus 5 plus 3. So this will be equal to 20%. And similarly, we can find the probability for picking 1, which is 50%, and for 2, which is 30%. Okay, so this is the equation. Now how can we solve this equation? The first approach that comes to my mind is, what we can do is, we can convert this array into something like this array. If you see carefully, in this array, 0 is present 2 times, which is equivalent to the weight of 0. 1 is present 5 times, which is equivalent to the weight of 1. And this number 2 is present 3 times, which is equivalent to the weight of 2. Now what we can do is, we simply have to choose a random number from this array. Correct? Now what we can do over here is, first let us try to understand what is the length of this new array. See, the length of this new array is based upon the sum of the weights, because 0 is present 2 times, 1 is present 5 times, and 2 is present 3 times. So the total size will be equal to the sum of the weight array given to us. This is the weight array given to us, so we will simply sum it up. So this will be the size of this array. So if this is the size of this array, the possible index for this new array is going to be something from 0 to sum of W minus 1. Correct? Now what you can do is, you can generate a random number between this range, and whichever number is present at this random number index, you can simply return that number. So suppose we generate something like 1. So we will go at this 0, this is 1. So we will return 0. If suppose we generate a number called 4. So we will go 0, 1, 2, 3, 4. So 1 is present, so we will return 1. So actually this will solve our problem, but we will run in one more problem because of this. So let me tell you what this problem is. See, it is given that in the constraints that the W.length lies between 1 to 10 to the power 4 and Wi lies between 1 to 10 to the power 5. Now let us suppose that the W array given to us is of length this 10 to the power 4, and all the elements that are present are 10 to the power 5. Then the sum will be equal to 10 to the power 5 into 10 to the power 4. Why is that? Because 10 to the power 4 elements are present in our array, and each element is 10 to the power 5. So the total sum will be equal to 10 to the power 5 and 10 to the power 4, which is equal to 10 to the power 9. Now in Java, you cannot have an array of size 10 to the power 9. The maximum size of array can be 10 to the power 8. So this approach will fail over there. Now let us try to understand another approach. This is the approach number 1. Let us try to understand one more approach. So what you can do is, this is the algorithm written over here. So this is what we are going to use in this question. Okay, so what you can do in this question is, this is the W array given to you. Now I'll create an array called W sum, which is the cumulative sum. So the first element will be 2, the second element will be 2 plus 5, that is 7, and third element will be 2 plus 5 plus 3, which is 10. Something like this. Correct? Now again, I will generate a random number, and the random number will be in this range only. So what you can do is, you can take the last number, which is equal to the sum of this weight, and you can simply multiply it with method random. Now method random is an internal function in Java. This function generates a number from 0 to 1, where 0 is included and 1 is not included. So if you see, if you multiply these two things, this will generate a range something from 0 to 10. Now I know that for 0, 1, the answer should be 0. As you can see, for 0 and for 1, we have zeros. So the answer should be 0. From 2 to 6, the answer should be 1. So if you can see, this is the index 2 and this is the index 6. Now what I'm doing is I'm still going to use this array, but I'm not going to build this array. That is the thing. The problem with the first approach is we are actually building this array, but we cannot build this array because there can be memory issues, correct? As I just told you. So we will simply use this array, but we won't be building it. Now for 7 to 9, if you can see, for this is index 7, this is index 8, and this is index 9. We have to return 2. Now how can we do this? Now we are not generating this array. Instead, we are generating this array. Now what you can do is, now suppose the random number generated is 0. So what you can do is you can simply iterate over this array, and whichever is the first index for which the random number is lesser, you can simply return that index. Correct? So suppose the random number generated over here is 4. So you will go over this. So is 4 less than 2? No. Then you will move over here. Is 4 less than 7? Yes. Then you will simply return this index, that is 1. So that is what we're supposed to return. So let me write the code for this, and then things will be more clear. So I'll keep an array called wsum, and this wsum will be equal to the length of w. Why w? Because this is the cumulative sum array, nothing else. So this will be of the size of w only. Correct? Now what I will do is I'll create a sum which is 0, and I'll iterate over the w array given to us. I'll increment sum by w of I, and w sum of I will be equals to sum. So we have created our w sum. Now when we have to pick an index, now we have to create, first you have to create a random number. The range of the random number is going to be something like this, correct? So if you see, this range can be achieved using this thing. Now the sum will be present at the last index of this w sum. If you see what this w sum is containing is the cumulative sum. So w sum 0 will be consisting of this sum, that is 2. Then w sum 1 will be consisting of sum of this array, which is 2 plus 5. And w sum 2 will consist of the sum of this array, this is 2 plus 5 plus 3. So the last index will consist of the total sum, correct? So what you can do is, now you will find a random number. So let us say random number, which will be equals to the multiplication of 10 into method random. So this will be generated at the last index of wsum array. So you will simply go wsum dot length minus 1 into math dot random. One more thing, this will generate a double, so you have to typecast this whole number into an int. Now what you can do is you can simply iterate from int I equals 0, I less than wsum dot length I plus plus. Now for the first number, if target is less than wsum of I, you can simply return that index. And if you are out of this loop, which is not going to happen, you can simply return a -1. Correct? So we have generated something like this thing. And what we are doing is we are generating a random number. Now after generating the random number, the random number must be in this range. That is what we took care of this by doing this thing. And then what we are doing is we are simply iterating over this, and the first number that we find which is greater than our target number, we will return that index. So I guess this is going to work fine. So let me just run this, submit this code once. Okay, so we are getting a compile time error. Okay, so I was making a couple of errors in the code. That is, I was not putting int over here, and instead of this random number over here, I was using a different variable, that is target. So I have changed those things. So let me submit this code. And it got accepted. Now actually I can improve on this solution as well. So let us see how. Now if you see this array carefully, this array is going to be sorted only. Why is that? Because it consists of cumulative sum. So cumulative sum is going to increase in case the numbers are positive. Correct? So this array is going to be sorted, so we can actually find the random number using binary search. So let us see how. So we can simply remove this thing. This is a linear search. Now we will define a result which is initialized to -1. We will have starting index which is 0 and index which will be equals to wsum dot length -1. Now I will say while starting index is less than equals and index, we will find mid using starting index plus and index minus starting index divided by 2. Now you can also find mid using starting index plus and index divided by 2. Both things are same. Now you will say if random number is less than wsum of mid, then in that case what you will say is, you will say result equals mid, and since you have to find the first number with which random number is lesser, so you have to shrink the window on the left hand side. So in this case what you will do is you will say and index will be equals to mid -1, and else you will simply say starting index equals mid plus 1. So let me run the result over here and let me submit this code. So it got accepted. So I guess that's it from this video. In case you have learned anything from this video, you can hit that like button, and in order to support my work, you may consider subscribing to my channel. Thank you all.